Hello guys, I'm back recording the second part of 4.1 anti-differentiation. The first part took about 40 minutes to go over how to evaluate indefinite integrals using some of the basic rules that we talked about, like exponent. Well, no, it's not called exponent rule. It's called power rule for antiderivatives. That one was a big one. Remember, that's the one where we increase the exponent by 1 and divide the term by the new power. We also talked about the logarithm rule and the exponential rule. So the first video kind of took care of how to integrate all these different indefinite integrals. And we also talked about, don't forget to put plus c, right? Don't forget to put plus c because the antiderivative that we found is not unique. We can have any function of that family with a different constant being added, and they will still have the same derivative, right? So that's why we had to always put that plus c, and we call that constant of integration. But today, we're going to try to look at a couple examples that will let us find what that constant of integration is. And those helping points are called initial points. So what I'm going to do today is, in this video, I will go over 3 examples involving the same indefinite integrals, but we're going to be able to find what the constant of integration is using the initial points. And then after that, I will ask you to try one problem for 4.1 daily problem. Okay? Every lesson videos, I will start talking about your exam 3. Now, I talked about exam 3 in the first part of a 4.1 video. You will have exam 3 next Thursday from 9:30 to 11 a.m. And if you can't make it, you need to email me and let me know, okay, so that we can schedule something. I feel a little bad as I have to cover 4.3 and 4.4 that same Tuesday. And then the Thursday, I will send out your exam. But, I'm gonna promise, I will keep it short. I will keep it short, about just 8 problems, 1 from each section that we went over. So exam 3 will cover everything from 3.6 marginals and differentials to 4.4 only. Okay, and I'm gonna finish 4.4 next Tuesday. But before I even finish 4.4, I will have practice problems for you to try this Sunday, by this weekend. I'll have something posted for you so that you can start studying for it early, okay? So let's go to the, what page were we on? Page 4. Let's go over example 5, 6, and 7. And then I will open up Canvas on my app, on my iPad, and then we'll take a look at 4.1 daily problem together, okay? Number 5. So what's this initial condition? Can you guys hear my neighbor's? He is so loud. I don't know if this is bothering you. I don't know if you can hear that dog, but I can hear that dog. What is going on outside? What are you doing every day? He's barking every day. What's he barking at? Nothing. All right, I'm back. Okay, so when a condition that is a solution of an antiderivative is given, now, when a point that is a solution, I'm going to highlight that word. Because what's the point, guys? Point is an x value and a y value, right? If we have a point, we can plug in that x value and y value. And the less variables that we have, we may be able to solve for that one left unknown variable. And we'll be able to solve for c. So no more that awkward plus c. We'll be able to actually replace the c with some kind of number if we have a point called, just a point they give. It doesn't have to be a specific point. Any point on that, the function will help us solve for c. And this given point is called initial condition, okay? Doesn't have to be the very first point with x value of 0 or t value of 0. As long as they give you some kind of point with x and y value, you can solve for c. Okay, and we're going to do that, for example, 5, 6, and 7, okay? So let's first look at number 5. Find the integral of 2x plus 3 dx. Given that, oh, look at that. This is the initial condition they're giving you. f of 1 equals negative 2. What are they saying? X is 1, y is negative 2. This is their initial point. This is the initial point they're giving you. Ignore that picture for me. That's the answer to this problem. But I just wanted to show you a picture after we get the answer ourselves, okay? So we're going to first evaluate this indefinite integral by the properties that we talked about in our previous video. So I'm going to use the property that says that when you're taking the integral of sum, I can separate these as sum of different integrals. I'm going to go ahead and write integral of 2x dx plus integral of 3 dx. I separated them. And another property stated that I can pull out the constant. I can pull out the 2. So I can do 2 times integral of x dx plus, now hold on a second, I was going to just copy down the same thing. But let me go ahead and evaluate that right now, okay? What is the antiderivative? That's going to be 3x plus c, right? 3x plus c. Now, let me go ahead and work with this guy now, okay? I'm going to evaluate that integral. That's going to be 2 times. Remember, we're using that power rule. Go up, increase the exponent by 1. So 1 will go up to 2, and you divide by that new power. So if you evaluate that integral, you will get x squared over x plus c, right? Don't forget that constant of integration. And then I'm going to go ahead and simplify this. Canceled out, that 2 is gone now, and I can combine this c plus c, and we don't have to call it 2c, okay? We're just using c as some arbitrary constant number. So I'm just gonna say x squared plus 3x plus some other number c. Now this is f of x. Okay, but here's the thing though. Didn't they say this function goes through the point 1, negative 2? So here's what I'm going to do. I'm going to plug in 1 for x and negative 2 for y. So I'm going to get negative 2 equals 1 squared plus 3 times 1 plus c. Okay? If I evaluate this, I'll get negative 2 equals 1 plus 3 plus c. Negative 2 equals 4 plus c. Therefore, c comes out to be negative 2 minus 4, negative 6. So c is negative 4, so I can give them, hey, the big f of x is x squared plus 3x minus 6. And if you find the derivative of this, if you find d dx of, or maybe it's easier for me to write the prime notation. What is big F prime of x? That's going to be 2x plus 3, right? Isn't that the integrand? Yeah, so we got it. And we know it has to be negative 6 for the constant, right? Now, take a look at this picture with me. We found the answer. This is what you're going to do, for example, 6 and 7 in your daily problem. But this, if you take a look at this picture that I copied from your textbook, we have 1, 2, 3, 4, 5 different functions. They're all different functions because they got different constants, right? But if you take the derivative of all these guys, this will turn into 2x plus 3. This will turn into 2x plus 3, 2x plus 3, 2x plus... All of their derivatives are 2x plus 3. So how do we know that this was the only one that will satisfy this problem? What made us know that this is the only one that is the right answer here? Because this is the only graph that goes through the point 1, negative 2. And the other ones did not go through 1, negative 2. So that's what's happening. Out of all these antiderivatives, we were finding that only one that satisfied that initial point, okay? Initial condition. So that's what we're going to do. Let's try another one on number 6. Number 6, physical science, height of a thrown object. A rock thrown upward at initial velocity 50 feet for... Okay, I'm going to go ahead and highlight this word. Initial velocity 50 feet per second from 10 feet above the ground. All right. So this object is not at 0 feet. At time 0, before you throw this, it's at 10 feet above the ground. Maybe a 10 feet tall person is holding it, or maybe you're just standing at like a I don't know, cliff, or I don't know. You're standing somewhere 10 feet above the ground. That's where the rock is. But you're going to throw it upward with an initial velocity of 50 feet per second. Okay? Now, they give you that the velocity is modeled by v of t equals negative 32t plus 50. That's the velocity function. Okay, that's the velocity function where t is the number of seconds after the rock is released and v of t is in feet per second. You know, in the previous section, we usually found velocity function from a distance function by taking the derivative, right? Look what they did. They gave you the velocity function first. So what are they going to ask you to do? They want you to determine a distance function h as a function of t. In this case, because I was thinking if they're asking for distance function, why don't you call it d? Why are you calling it h? Well, they said in this case, distance is the height of the rock. Okay, so here's what's happening. So far in our previous classes, you were given h of t. And then I ask you to, hey, can you please find the velocity function v of t? And how did you find v of t? V of t was simply the derivative of h of t, or d of t, the distance function. And then if you go on one more step, if you take the second derivative of h of x, we call that acceleration function, a of t, right? So here's what they give you. They gave you the velocity function, and they're asking you to go backward, go reverse, and find the distance function. So we're not taking the derivative of this v of t. If you take the derivative of v of t, then we go down to, we go to acceleration function. They don't want that here. They want you to go backward. So they're asking you, what kind of function has a derivative of negative 32t plus 50? What are they asking you to find? They're asking you to find the antiderivative, okay? So let's go ahead and find the indefinite integral of negative 32t plus 50. And can you please write dt after it, okay? All right, let's find it. I'm going to go ahead and separate these using my rules. Negative 32t dt plus integral of 50 dt. And then I'm going to pull out that negative 32 constant in front so that I have something like this. And then I can go ahead and evaluate. I can go ahead and write that this is equal to 50t plus c, some constant c, right? This is just using what we talked about in our first part. And then let me go ahead and evaluate this t dt. The original exponent is 1, so you go up by 1 and then divide by that new power. So integral of t dt is going to give you t squared over 2 plus the constant of integration c. Now let me just copy this 50t plus c down. And let me go ahead and simplify this. I can simplify this negative 32 divided by 2 and get negative 16t squared. I'll bring out that plus 50t. And I know we want to combine this c and the other c and call it 2c, but we don't have to. We're just going to say plus c for some constant c. Just some constant c. Now, this is the height function. This is the height function, or they wanted us to call it distance function, so I'll call it distance function. So h of t is negative 16t squared plus 50t plus c, simply by evaluating that indefinite integral. But I should have probably highlighted in a different color. I'm going to go ahead and highlight this very important information. Not that part, not the initial velocity part, but initial height above the ground, 10 feet above the ground. So at time 0, this was 10 feet above the ground already, right? So, I mean, if you look at that carefully, what they are saying is at time 0, this was at 10 feet. At time 0, at t equals 0, this was 10 feet above the ground. I'm ignoring that 50 feet per second, but here's what you can do though. Initial velocity, so I'm going to say v of t is 50, negative 32t plus 50. You can solve this for t. And guess what you get? T equals 0. So at t equals 0, well, that's what they mean by initial, guys. At time 0, the velocity was 50 feet per second, and that was from 10 feet above the ground. Now, I'm highlighting that. Let me go ahead and just get rid of this. Why am I highlighting that? Because that's the initial condition. I'm going to go ahead and say initial condition for this problem. Okay, I'm going to plug in t equals 0. And I'm going to plug in this function will equal 10 at that value. So negative t 16, 0 squared plus 50 times 0 plus c. All right, if I go ahead and, I do want to use this room. If I go ahead and solve this for c, I'll get 10 equals 0 plus 0 plus c. What's that constant? C comes out to be 10. So let's give them that what's it called? The function, the distance function h of t. It's not just some function with the plus random c. We know that function must be negative 16t squared plus 50t plus what constant? Plus 10. So that is the distance function h, and we found that 10 by using the initial condition of 0, 10. Part B is asking you to find the height and the velocity of the rock after 3 seconds. Okay, I can find the height of the rock at 3 seconds by plugging 3 into this h of t. So that will be negative 16, 3 squared, plus 50 times 3, plus 10. All right, what's that going to be? All right, type this in your calculator for me. You're checking to see if I'm getting right. All right, if you type that in, you should get 16 feet. So, after 3 seconds, the height of the rock is 16 feet above the ground. Okay, now let's find the velocity at 3. Velocity of the rock after 3 seconds. So plug in 3 into the velocity function. If you do that, well, that's going to be negative 46 feet per second. And make sure you put the right units there. The velocity is negative because what's going down here? The rock is going down, huh? The distance from the ground to this rock is decreasing. So it came out to be negative 46 feet per second. So what does that mean? This is moving downward. That's what they're saying. This rock is getting closer to the ground. And that was part B. And we are done answering number 6. So it's a super application problem. That was a very good one. Let's do the very last one. Example 7. And this is about life science fossil fuel displacement. Since 2013, the rate of change, huh? So they're giving you the derivative already. The rate of change in the amount of fossil fuel displaced, not needed, global displaced. Oh, that's a verb here, huh? They don't need it anymore globally because of electric vehicles, and that can be modeled by this function. D of t equals, it's a long function. All right, so what are we doing with this? All right, where d prime of t is in thousands of barrels of fossil fuel displaced per year, and t is the number of years since 2013. I hate it whenever they do that. So for 2013, t equals 0. So if I'm looking at 2020, t will be 2020 minus 2013. Okay, so I'll remember that. And I will also remember that this is given in thousands of barrels of fossil fuel. Okay, so in 2016, I'm going to go ahead and write down what this is. If you have 2016, t is going to be 3, right? Because 2016 is 3 years from 2013. Okay, approximately 24,638,000 barrels of fossil fuels were displaced globally. Sources based on data from Bloomberg New Energy Finance, May 2018. Okay, so what they want you to do here. Now, I think I'm going to go ahead and take notes here. I got the initial condition to be 3, 24,638. So that's the initial condition that we're going to plug in to find the constant of integration later, but we're going to have to first integrate that d prime of t first. All right, find the function d of t that models the amount of fossil fuel displaced t years since 2013. So let's find the integral of 1696 t to the third power minus, I'm just copying the function down, okay? T squared plus 420t minus 7808. And what do I need to write after that? dt. Okay, so let's evaluate that because that is what d of t is, okay? So what's that integral? Guys, if I use properties, it's gonna take a couple lines here, but I think we are at a point we know how to use these properties and write a little less work. Okay, so let's go ahead and do each of these. Okay, each of these separately. So I'll do this much. So first, increase the power by 1. Go up to t to the fourth power, right? But keep that number in front of it the same. But you're going to divide by the new power of 4. Okay, so we're done with that piece. Our next one, let's do this one. It was minus 14,091 t squared, but increase the exponent by 1. So t squared will now turn into t cubed, but you need to divide by what number? The new power of 3. Okay, doing good. Next one, I'm going to do this one now. Plus 30,420 used to be just t, but go up by 1, so t squared, and divide that by what number? 2. All right, the last one, this one. Minus 7808, and go up by 1, I guess the constant rule, and then if you divide by 1, that's just going to be that. But don't forget to put plus c, and that c represents c for everybody combined together, if that's okay. All right, so it's a nasty looking equation. I wonder if I can simplify this, or do I really have to simplify it? I don't feel the need to. Do I have to? Now let's think. Is it gonna be any prettier? All right, let's try it. Why not, guys? Okay, so let me see if I can divide these numbers, and I hope they turn out nice. I'm gonna divide the first fraction. What is 1696 divided by 4? Oh, that was nice. Oh, I'm excited. This one came out to be 424 t to the fourth power. Yeah, that one really came out nice. Minus 14,091 divided by 3. Oh, that one is also nice. 4697 t cubed. Plus, and that one's got to come out nice because that's just half of an even number. 15,210 t squared, and minus 7808. Oh, sorry, no x in this problem, no x, but what letter? T in that problem, plus c. So, okay, I'm glad I simplified it. I found the d of t that models the amount of fossil fuel displaced in t years since 2013, and ta-da, that's the equation. But. That's c, right? We can replace the c with some real good number. Let's plug in our initial value. The initial condition, I keep calling initial value. Initial condition is 3 and 24,638. I'm going to go ahead and plug those numbers into this equation. 24,638 go to the left side. And I'm going to plug in 3 everywhere I see t. 3 squared minus 7808, 3 plus c. And the only variable that I see is c there. So I'm going to go ahead and just bring this number down. And I'm going to work on my calculator, okay? I'll go ahead and evaluate what this is. And I'll go ahead and write that number down. 424 times 3 cubed, 3 to the fourth. Minus 4697 times 3 cubed. Plus 15,210 times 3 squared, minus 7808 times 3. When I did that, I got 20,991. 20,991 plus c. So if I subtract both sides by that 20,000 number, 24,638 minus 20,991 gives you c comes out to be 3,647. Ta-da! All right, I found it. So I can give them the real d of t, the one that doesn't have c. So let's go in and write that down. D of t equals 424 t to the fourth minus 4,697 t cubed plus 15,210 t squared minus 7,808 t, and then plus 3,647. That's the d of t. And now let's use this to estimate the amount of fossil fuel that will be displaced in 2020. Oh, okay. So for 2020, what should we plug in for t? 2020 minus 2013 will give you 7, right? So t is going to be 7 in this case. So plug in 7 and find the amount of fossil fuel that will be displaced in this year. Probably more now, because who drives nowadays? I'm writing this down. Equals. Okay, I'm going to go ahead and type this on my calculator. 442, 7 to the fourth. I hope it's not too big so that my calculator can give me an answer. Sometimes, you know how we get a number that is way too big and the calculators cannot handle, but it's got some subtracting terms stuck here and there, so hopefully it's not that big. All right, guys, I typed this into my calculator and I got a I don't know how to feel about this number. I got a number that's 101,000. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 101,234. Okay, so that's going to be the answer. But this is what I think they were measured in thousands, right? There were thousands. So let me go ahead and write this down. 101, 234. But because they were measured in thousands, right? Thousands. If I multiply this by 1,000, this implies 1, 0, 1, 2, 3, 4. I'm multiplying. Wow, that's like 1 million, 101, approximately like 101 million. What's the unit? Barrels. Is that how I spell barrels? No, I think I just need one L there. Barrels. So, that's it. That's how we used indefinite integral. Well, we were given the derivative function, d prime of t. We found d of t using the initial condition of 24,638. Plug them in, find the actual c, and we were able to use that good equation to estimate the amount of fossil fuel for a certain year. So that's probably enough for initial condition problems, and we got to look at some application problems in this video, so that's really good. Now I want to take a look at the word problem that you're going to try for me for 4.1. Okay, so I'm going to go over there. Where are you? Modules. 4.1 problem is right here. Oh, looks like somebody submitted it. Okay, a drone has a velocity given by v of t equals negative 0.6 t squared plus 4t, where v of t is in kilometers per hour and t is the number of hours since the drone took off. Find the total distance traveled during the first 3 hours. Now, if you read this problem, I'm giving you the velocity, right? But what am I asking? I'm asking you for the total distance. So given a velocity function, can you find the distance function? Yes, right? Didn't we do that over here? We were given the velocity function on number 6, but we know if you take the indefinite integral of the integrate that velocity function, that's how we get the distance function. So first thing you're going to do when you're working on this daily problem is you need to integrate that v of t. Okay, find the distance function. But when you find that distance function, you will get that plus c, right? You're going to have to solve that plus c here. And if you read carefully, I said, you will need the constant of integration in your final answer. You're not going to have a plus c in your answer. Think about the initial condition. What's the distance at 0? Because like unlike that one problem that we went over together where the ball was already, or was it a rock? A rock was already 10 feet above the ground. This drone at time 0, where is this drone at? Didn't travel anywhere. Didn't really say anything like that. Let me read it again. They're giving you the velocity function and where v of t is in kilometer per hour and t is the number of hours since the drone took off. Now, t equals 0 is 0 seconds after the drone took off. So at time 0, what's the distance that this drone traveled? That better be 0, right? So here's the initial condition given to you suddenly. That initial condition is that time 0, your drone traveled nowhere. So 0, 0 is going to be the point. So hopefully in your answer, you do not include plus c. If you include plus c, I'll probably give you like a 90 and send it back, okay? But try this problem for me. You know you're going to have to find the antiderivative and then solve the answer. I want you to find the distance traveled during the first 3 hours, okay? All right, I'm still waiting for your 3.9 problems. About 10 of you submitted it. But just like I said, we talked about it, do not find dp dt in this problem. dp dt is given to you as $2 per day. The price is increasing $2 per day. What we are asking is the rate at which the shares are being purchased, the change in